The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of an Imperfect Square. Here the example is 84,697. In an earlier example, 24,697, we straightaway considered the first three digits and found out the perfect square root, which is 15 for the first three digits. In the example 46,369, we straightaway considered the square root 21 by looking at the first three digits of the number. Children may be comfortable remembering multiplication tables up to 20 or 25, but it becomes difficult beyond that. Do we always have to take the first three digits for calculating the square root in the case of an odd number? It can be when the child knows the perfect square in those three digits. In case the child is not familiar, then smaller groupings may always be done. We have altered the example 24,697 and considering 84,697 by changing the first digit 2 into 8. The child may not be knowing the perfect square in 846 and therefore it cannot be treated as a single group. In such cases, there is no need to worry and we can always proceed with the problem by breaking that into smaller groups. Let us consider the three groups as 8, 46 and 97. Let us set the number 84,697 in the abacus by leaving the last three columns for finding out the decimal part of the square root. That is, 7 is set in the thousands column and 9 to the left of it, 6 to the left of 9, 4 to the left of 6 and 8 to the left of 4. Take the first group 8 and consider the highest perfect square here, which is 4. Therefore, take the square root 2 of this perfect square 4 and that should be set by skipping a column to the left of 8. Now multiply 2 with 2, which is 4, that should be subtracted from 8 and which gives the remainder value as 4. Now take the second group with this remainder and then the number becomes 446. That is, in the first group you get the remainder 4 and in the next calculation you have to add it with the second group. So the number becomes 446. Now double the number 2, which is the square root so far, and set it at the left extreme of the abacus. It is a typical situation you get as there are 11 4s in 44, the first two digits. In such cases, you take the highest single digit as the quotient. Therefore, set 9 to the right of 2 and also to the right of 4. That is, multiply 9 with 49 and subtract the same from 446. That is, 9 multiplied by 4, that is 36, and you should subtract 3 from 4, and for subtracting 6 from 4, you subtract 1 in the higher column, add 4 with the already existing 4, that makes it 8. Now multiply 9 with 9, which is 81. That should be subtracted from 86. That is 8 subtracted from 8 and 1 subtracted from 6, and therefore you get the remainder as 597. In the next stage, double the square root part 29 and set 58 in the left extreme of the abacus. Now consider 5, the highest digit of the number on the left, and 5, the highest digit of the remainder. As the divided value is 1, set it to the right of the existing square root, which will make it 291, and also set that to the right of 58. Now 1 multiplied by 581, that should be subtracted from 597, and you will get the remainder as 16. Now you have to go for your decimal part of the square root. Add 0 to the dividend, which is making it 160 at this stage. Now from here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 291, which is 582. Since 582 is less than 160, your first decimal digit of the square root will be 0. Now add one more 0 to the dividend and you get 1600. When you are going to the second decimal of the square root, you can round off the divisor and get approximate values. Now round off the divisor 582 into 600 and ask how many 600s in 1600. By saying 2, place the value to the right side of the present square root, that is 291.0, and therefore you will get the square root as 291.02 at this stage. Now subtract 2 multiplied by 582, which is 1164, and this is subtracted from the 1600 and you get 436 as the remainder. As this is higher than the midpoint 291 of the remainder 582, the decimal part of the square root may be rounded off to 291.03. We have demonstrated here that when you have the first 3 digits of the number which are higher and having a square root beyond 20 or 25, the child may not be able to remember by heart, and in such cases it is always better to go for smaller groupings instead of combining them. One word of caution is important in doing square root problems. The placement of the digits in the abacus is very important. We have demonstrated here so far that no calculation is running into the next calculation. That is the beauty of the abacus. However, the placement of number in the right column is very important, as missing that even by a single column will lead to complications, and you may have to reset the entire problem. That is why when you do problems in higher level operations such as the square root, placement of the right number in the right column is absolutely essential.